Okay, folks, so this one's very similar to the last one. I'll call this one number two. But very similar. And we're gonna again, it's a table, and a ball is rolling off, and it falls. It says it falls. What is it? 4 meters from the base of the table. So it falls 4 meters from the base of the table, and it says the height of this table is a little taller. So obviously it's going to take longer to fall, but it's 2 meters tall. And they want to know what is the speed of this ball when it rolled off. So remember that question is going to be in x. And what's cool is that means all we need to know is how far it moved divided by the time. That's it. Now, how far did it move in the x direction? 4 meters, right? So it moved 4 meters. Divided by, the time. The time it takes, how long did it take to get from this spot right here, over here, to right here? How long did it take? Well, really, that has nothing to do with this. Has nothing to do with that. It has something to do with this, right? The taller the table, the longer it takes to fall. So again, we need to go to the y position. I'm going to start up here because it's going to be a little bit longer. We're definitely looking for time. How long does it take? And we do know that this object is going to move in the y position. Sometimes they'll call this delta y just to give you guys an idea, but I'm just keeping it delta x since we are dealing in the y position. They will call it delta y, but it means the exact same thing. I just don't want to change all the equations around and confuse everybody. But the change of position is negative 2 meters because you're going to start here and you're going to end 2 meters below where you started in the y position, up and down, right? Remember, because this is the up and down position, x is the left and right position. So in this dimension, we're doing two dimensions here. It's negative 2 is the change of position. And we know that a is negative 9.8 and meters per second squared. And we know that the initial velocity is 0 because it just fell off. It did not get thrown downward. It did not get fly upward at all. The second it left that table, it just kind of fell in the y direction anyway. Yes, in the x, yes, it was going very quickly or maybe slow. I don't know. We don't know the speed. But in the y, it literally just fell off. It will speed up and head downward, but we don't really care. We're just trying to figure out the time here. So for this, we're going to use delta x is equal to initial velocity times time plus 1/2 at squared. And remember, this is all 0 because the initial velocity is 0. So we'll plug this in here, and we get this equation right here. And we're going to figure out time. So let's plug everything in. Negative 2 is equal to 1/2. The a is negative 9.8. And the t squared. And this ends up being negative 4.9 times t squared is equal to negative 2. And then let me roll this down just a little bit. Oops. Okay, I'm going to have to scroll. There we go. And then let's divide by negative 4.9. Divide by negative 4.9. And this is good. Divided by negative is going to be positive. That's good because we're going to get time here. And we can't take the square root of a negative number. That's just weird. So let's do that math real quick. Let's bring out the calculator. And we're going to do 2 divided by 4.9. And then I'm going to get 0.4. So I'm going to get 0.4. But we're not done yet because that's what time squared is. I don't want to know what time squared is. I want to know what time is. So let's square root both sides. And we'll get t is equal to the square root of that. And I could just take the square root of that. I'm going to take the square root of this. I know it's not exactly 0.4, it's 0.408. This is more accurate. Square root, where is that? I lost it. Well, let me go back to my standard calculator. Oh, I lost it. Okay, now I'm going to take 0.4 and square root it. It was probably on the other page. I just didn't see it. It's 0.63. So 0.63 seconds. Do I need a round? No, I don't. So 0.63 seconds. So here's the amount of time it took, 0.63 seconds. So I'm just going to put that right there, in there. And then just divide this. 4 divided by 0.63. Let's do that. 4 divided by 0.63. And it must have been going 6.35. We can round that last 4 right there. 6.35 meters per second. So the answer is 6.35 meters per second. That is how fast the ball was rolling. So now we know the speed, and that's all there is to it. It's a simple problem. It's kind of very similar as the last time, except this time we're kind of working backwards a little bit on the x side. Still trying to figure out that time, and then we use the time here and the distance to find the velocity. Before, they told us the velocity, and we calculated the time to look for this, but now it's kind of the other way around. That's all. That's the only difference. Try one of the practice problems out. You can write these notes down and try it out and practice with it.